All right, so now we got simplifying rational expressions. So if you might remember, rational expression or rational number is a fraction. So this is going to be dealing with fractions, essentially, of polynomials. So a rational expression is a quotient, right? Quotient is just a fancy word for division, right? So it's the quotient of two polynomials. So that could be something like x squared plus 1 over x squared plus 2x minus 3, right? It could be something like x over x squared minus 1. It could also be something like 4 over x minus 2, because remember, 4 is a polynomial, right? It's called a constant polynomial, or vice versa, right? Good. So when it comes to rational expressions, right, remember, you cannot divide by 0. Otherwise, it's called an undefined number, right? It's undefined if you divide by 0. So this means that we have to exclude all of the values that makes the denominator equal to 0. So, for instance, with this one, right? Let's find all the numbers that would make the rational expression, excuse me, undefined. So that means that the denominator, the one on the bottom, right, that can't equal 0. So if it does equal 0, what would x be? What x makes this equal to 0? So we see that 7x would equal 28. So x would be 4. So we need to exclude 4. X can't be 4. Let's look at part B. So if we have x squared plus 3x minus 10, right? So if we say what x's make that equal to 0? So if we have factoring, right? What two numbers multiplied gets you negative 10, adds gets you positive 3. So hopefully you can see that that's positive 5 and negative 2, right? 5 times 2 is negative 10. 5 plus negative 2 is positive 3. So that would mean that x would equal negative 5 and x would equal positive 2. So we need to exclude negative 5 and 2, right? Because negative 5 makes the denominator 0, which is bad, and 2 makes the denominator 0, which is bad. All right. So, simplifying rationals. So, first thing you want to do is factor the numerator and the denominator completely. So, once you have it to where you're getting to the simplifying part, you want to factor the denominator and the numerator. Then we divide both the numerator and the denominator by any common factors. So if you have something like p times r over q times r, right? R's are on the top and bottom, so those get canceled. So it'll be p over q. Now notice, a common mistake that I see with students is typically they want to do, if it's an addition, p plus r over q plus r, that does not equal p plus 1 over q plus 1, right? It's because there's an addition sign, right? With here, on the first case, they were being multiplied, so they are factors, right? They're factors when you're being multiplied. When you're adding, they're no longer factors, right? So this entire term on the top is p plus r, whereas here we have one term of p and one term of r. Right? It's because it's adding. So if adding or subtracting, you can't simplify like this. And we can just see real quick, right? So quick example. You can see that 3 plus 2 over 4 plus 2, right? So if you could do it this way, then that would mean that the 2's can simplify down to 1's, right? So 3 plus 1 over 4 plus 1. So that would be 4/5 is the same as 5/6, right? Which obviously isn't true. 5/6 is 0.83 repeating, and 4/5 is 0.8, right? And since those aren't equal, these cannot be equal. So make sure it's only when it's being multiplied. You do not do it when it's being added. You have to do the entire term if it's added. So let's simplify. So let's factor the top. So we can see that 5 is in common with both terms, right? So we can rewrite that as 5 And then what times 5 is 5x? X. What times 5 is 35? 7. So we see that the top is going to be 5 times x plus 7. We can also factor out the bottom, right? So we can see that 20 is 5 and 4, 2 and 2, right? So we can say that that's 2 times 5 times, 2 times 2 times 5 times x. So then we take out what's on the top and the bottom. So there is a 5 here being multiplied, and there's a 5 here being multiplied. So those are canceled. Now, can we simplify the x's? No, because this x is being added, right? So the only way to simplify this is if you had an x plus 7 on the bottom, which we don't. So the way to simplify this is going to be x plus 7 over 2 times 2 is 4, 4x. So that's simplified. Number 3. All right. So what can we take out of the top? So we can notice that there is an x squared in common with both of them. So you can take out an x squared, and you're left with x plus 1. In the denominator, there's nothing left to take out, so you just have x plus 1. So we can see that there is an x plus 1 on the bottom and an x plus 1 on the top. And since there's an addition, you have to have the entire thing, right? So x plus 1, x plus 1. There we go. We can cancel all of that out. So we're just left with x squared. Number 4. All right, now we're getting a little harder. So if we are going to factor out the top, right? What two numbers multiplied gets you 5, adds gets you 6. Hopefully you can see that that is a 5 and 1, right? 5 times 1 is 5. 5 plus 1 is 6. And then if you notice this, oh, well, this is going to be the difference of two squares, right? X squared minus 5 squared. So that's x plus 5, x minus 5. So we can see that we have an x plus 5, and x plus 5 on the top and bottom. So we are left with x plus 1 over x minus 5. And that's the simplified answer. All right, number 5. So for the first one, for the top, we can see that this is another difference of squares. So we get 2x squared minus 5 squared. So we get 2x minus 5 and 2x plus 5. On the bottom, we can see that there is a common factor of 3. So you can take out a 3, and it is 5 minus 2x. Now, we can see that the top is 2x minus 5 and 5 minus 2x. So this is almost the same, except there's negatives, right? We can see that the signs are flipped. So you can also take out a negative. So we can see that instead of a positive 3, we could take out a negative 3. So you take out a negative 3, right? Instead of positive 5, it's negative 5. Instead of negative 2x, it's positive 2x. And then we can switch these around. 2x minus 5, 2x plus 5, negative 3. So the positive 2 and negative 5. Yeah, you can't just switch it like this, right? Negative 2x is not the same as 2x minus 5, right? In this case, negative 2x is negative. In this case, 5 is negative. Those are two different things, right? That's like saying 1 is the same as negative 1, and obviously it's not. All right, so now we see that we can get rid of the 2x minus 5 and the 2x minus 5. So we are left with 2x plus 5 over negative 3. Last problem. All right, so we got 49 minus 9x squared over 12x minus 28. So again, in the top, we can see that we have a difference of squares. So that's 7 squared minus 3x squared. So the top is going to be 7 minus 3x, 7 plus 3x. In the denominator, we can see that the greatest common factor between these two is going to be 4. So 3x times 4 is 12x, and 7 times 4 is 28, or negative 7. So again, we can see that the top is almost like the bottom, right? So if we want to just take out a negative, right, we can take out a negative from that bottom instead. So we take out a negative 4, we see that's going to be negative 3x plus 7. We can rotate around so that way we can see that it's the same thing. Oop, negative 4. So 7, negative 3x. Right, so these two are canceled. And you're left with 7 plus 3x over negative 4. And that's our final answer. All right. If you have any questions, let me know. Otherwise, we are done with the first section. Have a great day.